as a condition. And coming to the next one, even signal and odd signal. Here, the even signal means the signal exhibits symmetry in the time domain. So, in the time domain, in the sense, your x-axis parameter is your time domain, whether it is a continuous domain or it is a discrete domain. X-axis will represent your time domain parameter, and if the signal exhibits a symmetry in time domain, then we call that signal as a even signal. The best example is the cosine waveform. Look at here. So look at this waveform. This is my cosine waveform, isn't it? Cosine waveform means at the point of 0, that is at a 0 value, then my amplitude will be the maximum 1. And if I am changing my value, then it goes on decreasing, isn't it? And one particular point of time, it will reach 0 and then go to the maximum negative and back to 0 position. So the same thing will be repeated in the left side of my y-axis. So with respect to y-axis, if you deal the signal, if you have both sides similar to each other, then we call that signal as a even signal. We might have remember in our childhood days, we play a game, that is we are dropping a ink on a paper and fold it. Then we will have the dots on either side of our paper, isn't it? So we can remember this as a example for our even signal. So the best example for the even signal in the waveform side, we can check it as a cosine waveform. Remember that cosine waveform means at t is equal to 0 or n is equal to 0, the amplitude value will be a maximum 1, right? So on either side, we will have the same pattern. That is the even function. So I can say my even signal in a mathematical way, x of t is equal to x of minus t, or x of n is equal to x of